Welcome to InstaSPIN-MOTION. InstaSPIN-MOTION delivers maximum control with minimal effort for motor applications. Building upon InstaSPIN FOC's sensorless, field-oriented control, InstaSPIN-MOTION adds optimized motion profiling, single parameter tuning, and a disturbance compensating controller which provides accurate trajectory tracking across speed and load ranges with a single gain. In this video, you'll see the impact of InstaSPIN-MOTION on a treadmill application. The motor is the heart of the treadmill. The motor rotates the belt as you walk, jog, or run. The motor not only moves the belt, but it must also overcome the resistance of each stride. One of our field application engineers recently visited a customer that was using a 4-horsepower, 220-volt AC induction motor to drive their treadmills.
Treadmill applications present an interesting control problem. Treadmills have to operate across broad speed and load ranges. For this treadmill application, the speed range varies from 42 RPM at the low end to 3,300 RPM at the top speed. The load range can also vary from less than 100 pounds to several hundred pounds. To emphasize this control challenge, one of the engineers stood on the belt while the speed was set to 100 meters per hour. Another engineer placed a foot on the belt, demonstrating that the motor had difficulty overcoming the additional resistance.
Adam, what alternatives does this customer have?
They could select a different motor. A motor rated for 5,000 RPM or higher will generate enough torque to drive the exercise belt. The problem is that this motor is likely to overheat and won't last very long. It will be difficult and time-consuming for the customer to tune the motor for all the different speed and load parameters. Swapping out motors could introduce other design changes which will increase costs. In the existing design, the customer wants to replace their drive with a more cost-effective solution. They also want to eliminate the physical sensor to reduce costs even further. A larger motor won't solve either of these problems. A better alternative is to use InstaSPIN-MOTION's advanced motion control capabilities. The beauty of InstaSPIN-MOTION is that it's easy to use. There's a lot of motor and motion control expertise embedded on the chip, so customers, regardless of their motor control knowledge, can get their applications up and running quickly with their motors operating at peak performance. For this treadmill customer, it enables them to design their own motor controls to replace the drive in their current application. InstaSPIN-MOTION has a single tuning parameter called bandwidth. We tuned the controller at the customer site in a matter of minutes. We saw consistent performance across the entire rated speed range of the motor by tuning the bandwidth one time. InstaSPIN-MOTION is sensorless, which means that this customer can reduce their costs even further by eliminating the Hall effect sensors that they use today. InstaSPIN-MOTION's advanced controller automatically compensates for disturbances. This means that it can prevent the treadmill from stopping when a user steps on it at low speeds, and it can keep the speed consistent as the user runs at higher speeds. InstaSPIN-MOTION also provides field weakening. The 4-horsepower motor used in this treadmill was rated for a maximum speed of 1,750 RPM. Through field weakening, the same motor can now achieve 3,300 RPM. Once the treadmill was controlled by InstaSPIN-MOTION, there was a visible difference in performance. One of the engineers stood on the belt while the machine was operating at 100 meters per hour. The engineer then applied an opposite force to the belt by grabbing the handrails.
Wow, that's pretty impressive. Before we applied InstaSPIN-MOTION, the engineer was able to stop the belt from moving just by putting his foot on the belt. Now, when the treadmill's under the control of InstaSPIN-MOTION, the belt continues to move even when the engineer applies his entire weight to stop it.
If we compare the existing design to a design using InstaSPIN-MOTION, the customer can solve their low-speed control issues, the tuning time is reduced to almost nothing, and they can eliminate the cost of the drive and the cost of the sensor.
So let's review the benefits of InstaSPIN-MOTION in this application. InstaSPIN-MOTION simplifies design. Because InstaSPIN-MOTION embeds motor control expertise on the chip, the customer is able to design their own motor controls. InstaSPIN-MOTION accelerates time to market. Some customers have told us that it's taken them 6 months or more to identify PI tuning parameters for all of the speed and load points in their application. In this treadmill application, there are variable speeds and loads, and yet the controller was tuned in a matter of minutes to function across the entire operating range. InstaSPIN-MOTION enhances product performance. It automatically compensates for disturbances that could stop or slow the belt. InstaSPIN-MOTION reduces overall cost. The customer can replace the hardware sensor in their existing design with InstaSPIN-MOTION's software encoder. Field weakening allows this customer to get greater output from a smaller, less expensive motor. And the customer is replacing the drive with the motor control that they're designing in-house. Contact your local rep or visit these websites to see what InstaSPIN-MOTION can do for your application.